Okay, this is video 5.8, solving polynomial equations. So our objectives here, we're going to identify possible rational zeros of a polynomial function, and we're going to find all the rational zeros. So we're going to identify all the possibilities and then use those possibilities, that's what we know, to find all the zeros. Okay, so really there's not a vocabulary. The vocabulary here is going to be rational zero theorem. Okay, so if we look at our, let's go to our notes here, 5.8, and look at the key concept box that I placed on here. Whoopsie, gone too far. All right, so what does the rational zero theorem say? It says, and I'm going to read it and then I'm going to put it in layman's terms. If p of x is a polynomial function with integral coefficients, then every rational zero of p of x equals 0 is of the form p over q. A rational number in simplest form where p is a factor of the constant term and q is a factor of the leading coefficient. So what they're saying, if you have a polynomial function with coefficients that are integers, then every rational zero, we're going to know what a rational number is, every rational zero of p of x equals 0. And we learned that a couple of chapters ago, or the last one with the remainder and the factor theorem. We reviewed that. Is in the form of p over q, a rational number in simplest form. And it could be 3 over 1, which is just 3, right? Where p is a factor of the constant term and q is a factor of the lead coefficient. So let's just go straight into the example and look and see what they're saying. So the example gives us f of x equals 4x to the 5th plus x to the 4th minus 2x cubed minus 5x squared plus 8x plus 16. So this is p. P is the constant term. So all the factors of 16. 2 and 8 and 4 and 4. Yes? And q is the lead coefficient. So that's going to be 1, 2, and 4. So we're going to take p over q of every possibility. So all these divide by 1, so it's always plus or minus, but I'm not going to 1 plus or minus. I'll write it this time, but I'm not going to write the plus or minus each time. Plus or minus 8, plus or minus 16. How I got these is 1 divided by 1, 2 divided by 1, 4 over 1, 8 over 1, 16. Now I'm going to do the next one, plus or minus 1/2, plus or minus 1/4. All right, I'm not going to do 1 over 1 because I already have it here. Now I'm going to do the next one, plus or minus 1/4, which I already have, plus or minus 2/4, which is 1/2, I already have, plus or minus 4 over 4, which is 1, 8 over 4 is 2, I already have that, and 16. So these are all my possibilities, right? So all they want us to do is list all the possible rational zeros. So these are our possible zeros. So we have 1, 2, 3, 4, 5, 6, 7 times 2. So we have 14 possibilities. And this is where Descartes' rule is going to come in. We're going to use that in a second. Let's look at B. That was a 1A. So B is f of x equals, I can barely read this, x cubed minus 2x squared plus 5x plus 12. So what is P? P is 1, 12, 2, 6, 3, and 4. Q is 1. So this is real easy. So P over Q is going to be plus or minus 1, 2, 3, 4, 6, 12. And there should be a plus or minus in front of all these. And those are all the possibilities of that one. So pause this. So all they want you to do here on this guided practice 1A and B is identify what P is. So all the factors of the constant term, that's P. And then all the factors of the lead coefficient is Q. It's just 1. And then you find all the possibilities. And they're all going to be plus or minus. So I just didn't put them originally. Right? So pause it and do that. Let's go to, so here they're actually giving us two real world problem. It says Adam is building a computer desk with a separate compartment for the computer. The compartment for the computer is a rectangular prism, as they show you. Okay, and will be 8,019 cubic inches. The compartment will be 24 inches longer than its width, and the height will be 18 inches greater than the width. Find the dimensions of the computer compartment. So we have to go and write the problem out. So we're going to let x equal the width, x plus 24 equal the length, and x plus 18 equal the height. Now we know length times width times height equals volume. So I've got x times x plus 24 times x plus 18 equals 8,019, because they gave me the volume. We have the dimensions. Now, what do you think we're going to do? We're going to multiply this, and we're not going to save time, so we're going to let the book do it for us. X squared plus 432x minus 8,019, correct? Equals 0. So we have to find all the zeros is what we're finding to solve for x. Now, according to Descartes' rule, we're going to have one sign change. So we're going to have one positive, exactly one positive. And then if we change, and we know we don't care about the negatives, right? Because we can't have a negative width. We're talking about measurements. So all we care about the positives, so we're looking for one positive. So this is Q and this is P. All right. Now, we're not going to sit here and factor this. We're going to let the book do it. The book did it for us, and they got 1, 3, and it's plus or minus 11, 27, 33, 81, 99, 243, 729, 891, 2673, and 8019 are all the factors. So we don't care about the minuses, we just care about the pluses. Now, we use synthetic division, right? And so they did 1. When they did 1, they got, I forget what they got. But when they didn't, it wasn't remainder 0. And then they did 2 and it wasn't remainder 0. And then they put positive 9 and they got remainder 0. Okay. So once they were done with that, they ended up with, so we know we have, and there you go. We only needed one positive, right? Because we know we're going to have one positive real root. And we don't care about how many negatives because we can't have a negative value. So we have W equals 9. And the length is 9 plus 24, which is 33. And then the height is 9 plus 18, which is equal to 27. So I have 9 by 33 by 27. If you multiply it out, you get 8,019, and we checked it off. Now, I'm not going to give you anything this difficult with this kind of factors. All right, they're going to be better numbers than this. So pause it, do the guided practice. It's basically the same thing. You're just finding the zeros. Okay, so let's look at example 3. It says find all the zeros, and this is really where we actually get in. We find the possible ones, and we use Descartes' rules to break it down. Okay, plus 41x squared minus 72x minus 36. So first I have what? 1, 2, 3 sign changes. So I'm going to have 3 or 1 positive root. Okay. Negative, imaginary, and then total. And I have a root of 4. Okay. So I'm pretty sure it's going to be 1 here and 0, but let's check it. So this sign is still going to be positive. This is going to be positive. right? Changes opposite. This is going to stay positive. This is going to be positive. That stays negative. So we have one sign change. So here we go. So this is 2, 4. So my possibilities of rational zeros are this row or this row. These are just possibilities. Okay, so now let's look at finding P. So P is going to be 1 and 36, 2 and 18, 3 and 12, 4 and 9 and 6. And what is Q going to be? Q is, remember this is P and this is Q. Q is going to be 1 and 5. So now we have to do P over Q, all our possibilities. So remember they're plus or minus. 1, 2, 3, 4, 6, 9, 12, 18, 36. Then you have 1/5, 2/5, 3/5, 4/5, 6/5, 9/5, 12/5, 18/5, and 36/5. All right. So the book does -1, and they get a remainder of 90. Okay, and then they do +1, and they get a remainder of -70. Then they do 2, and they get a remainder of 0. So we know, okay, so that's positive, right? Remember, because we're using the roots, the factors. So these are roots, and zeros, not factors. Factor would be x minus 2. So it's either, so we've got 1. So it's either going to be have 2 more, and we know for sure we're going to have 1 negative. So what's left when they do 2 are the coefficients. So you have 5, I'm going to change the color. 5x cubed plus 2x squared plus 45x plus 18. Now I can continue and start all over with this is P and this is Q and do P over Q and go from here, or continue using all these factors into the original equation. Either one doesn't matter. But I'm going to try and factor. So I'm going to group this together and this together. I'm going to factor out an x squared. I'm left with 5x plus 2. I'm going to factor out a 9. I'm left with x plus 2. So I have x squared plus 9. And hopefully I get lucky. Oh, this is a 5. And it's factorable. And it is. So then I get x equal plus or minus 3i. I set them each equal to 0. And when I solve for x, I get plus or minus 3i. And then I get x equal negative 2/5. So, and I already knew I had x equal 2. So 1 positive, 1 negative, 2 imaginary. So this is my, according to Descartes' rule, was correct in my solution. So that's why you kind of put 2 and 2 together. You find out what your possibilities are. Then you find out your, according to Descartes' rules, and then your possible rational root zeros with P over Q, and then we just got lucky. I mean, it could have been one of these numbers way down here. Remember, these are all, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 36 possibilities of synthetic division. Or put it in your calculator and do f of 2 instead of synthetic division, which I'm okay with as long as you do one set of synthetic division showing you know how to do that or know that that's a possibility. Then you can use your calculator to find the roots. But you use Descartes' rule to say, what kind of solutions am I going to have? I mean, you could have had 3 more rows of possibilities. In this case, it wasn't, but you could have, okay? So the rows are your possibles, and one of those rows are going to be the type of solutions you're going to have. We can use the rational zero theorem to try it. So pause, stop this, do the guided practice, and we will see you in class.